Okay. Okay, so today we're going to look at vectors and specifically application of our vectors. All right, so far we've gone over the unit vector. We've gone over rewriting a vector in terms of its magnitude and direction. So one of the things we know using our triangle is that A, which is the horizontal component of our vector. So A is the horizontal, and B is the vertical. We know that A is equal to the magnitude of the vector times cosine of theta, and B is the magnitude of the vector times sine of theta. We also know that from yesterday that our unit vector is equal to the vector divided by the magnitude of that vector. And the magnitude of a unit vector is equal to 1. So now we're going to take a look at some actual application problems of vectors. So imagine that you have a person and they're holding a box. What's the force, and that's the best I can do with the drawing. So you actually have two forces that are working on this box. You have a force due to gravity that's pulling down on this box. Now, if this box is not moving at all, so you're just holding this box, it's not moving, there's also a second force that's working on this, and that one's moving up. It's to counter the force of the gravity. So here, if we call this one force 1, and let's say the force due to gravity on this 10-pound package, so let's say the package is 10 pounds. So you have a force 1, and you have a force 2. If this package is not moving at all, then that means that force 1 and force 2 are equal. One of the forces is pulling down, negative, the other force is pulling up, positive. They're equal. They cancel each other out. So the resultant vector of force 1 plus force 2 will equal to 0. They're opposites of each other. Now, if the box starts to fall, then the force of gravity is larger than the force of you holding it there. If you start lifting the box up, then you're lifting it up with a force greater than the force of gravity. Okay, so let's take a look at a couple of examples. Actually, one definition first. So let's define this. Let's say if force 1 and force 2 are two forces acting on an object, so force 1 and force 2 are two forces acting on an object, then the net effect is the same as if the resultant force of F1 plus F2 acted on the object. Okay, so we're going to take a look at a word problem. Just a sec. Let me, if you guys get this one written down. All right, are we all set? Okay, so let's take a look at this problem. And we have two forces F1 and F2 of magnitude 10 and 30 pounds respectively, okay, so which force is 10 pounds? And which one is 30 pounds? Okay, so I'm writing this how you would see this probably written out on some sort of test. It would have been easier for me to just say F1 is 10 and F2 is 30, but you would see it probably written like this. So it's really key that we equate that F1 is the one that's 10 pounds and F2 is the one that's 30 pounds. So that's the magnitude of those forces. The direction of F1 is north 20 degrees east. And for F2, that one is north 65 degrees east. So the task is here is to find the magnitude and the direction of the resultant force. So what's the magnitude and direction of the resultant force? We may need a computer for this. Calculator. So find the magnitude and direction of the resultant force. All right, so let's take a look graphically of what we're dealing with. First off, the two forces, F1 has a magnitude of 10 and F2 has a magnitude of 30. What does the magnitude of a vector mean? What is its magnitude? It's its length. So right away we should know that F2 is going to be longer than F1. F2 is going to be 10, F1 is going to be, F2 is 30, F1 is 10. Now F1 is north 20 degrees east. So here's my north. If we're going east, which way are we going? To the right or to the left? To the right. So this is our east, there's our west, there's our south. So if we're north and we're 20 degrees east, then we're 20 degrees off of the northern axis here. So for F1, it's going to be 10 units long, and the angle is 20 degrees from the north. So there's force 1. And I probably drew it too long. So F1, and that's 10 pounds. F2, that one is 30, but it's north 65 degrees east. So here's north. Remember, from east to north is 90 degrees. So if we're 65 degrees east, what we're really going to be is 25 degrees off of this x-axis, because 25 plus 65 gives us 90. So if we go 65 degrees that way, then we're something like this. So this is F2, it's 30, and the angle here from the northern axis to this vector here is going to be 65 degrees. So now, what's our resultant force? How do we add these two? Okay, so what we have to do, if this angle is 20 degrees off of the northern axis, what is it from the standard position? So if I'm 20 degrees here, it's 70. So F1, theta 1, is going to be 70 degrees. If we're 65 degrees off of our northern axis here, then what does this angle measure from the standard position? 25. So theta 2 is equal to 25 degrees. So we have a magnitude of 10, angle of 70 degrees, and we have a magnitude of 30 with an angle of 25 degrees. Okay. So let's write F1 in terms of magnitude and direction. So F1 is going to be 10 times cosine of 70 degrees, I, plus 10 times sine of 70 degrees, J. You guys have calculators? Because 70 degrees, that's not on our unit circle. So F1 is going to be 10 well, they have their they can use their phones as a calculator. So what is the cosine of 70 degrees? Point what? Okay, 0.34. Give me one more number. Okay. And how about the sine of 70 degrees? 0.939, and then J. So 10 times 0.342 is going to be 3.42I, and then 10 times 0.939, and we're going to round this to 94, so plus 9.4 OJ. So as far as magnitude and direction, force 1 is approximately equal to 3.42I plus 9.4 OJ. So your horizontal is 3.42, our vertical is 9.4. So let's do the same thing for the force 2. So our second force, that one's going to be 30 times cosine of 25 degrees, and that'll be I, plus 30, which is our magnitude, times sine of 25 degrees, and that's our J. All right, ladies and gentlemen, go ahead and work that one out and tell me what that one. Okay, so F2 comes out to be 27.19i plus 12.68j. So 27.19i plus 12.68j. So that's F2. Did anybody get anything different? So you're going to round it to two places. Okay, now here's our resultant force. It's going to be the force of 1 plus the force of 2. So this is our resultant force. Just straight up atom. You know what? I took physics a long time ago. I would hope so. But you guys are doing algebra-based physics. You're not doing calculus-based physics. So, but I am sure that when they're doing resultant force and this sort of thing, it's the same thing. So then this would be, so 3.42i plus 9.40j plus 27.19i plus 12.68j. Now, 2 days ago, we learned how to add vectors. So how do we add these two vectors? We add the like terms. So our resultant force is going to be, and then for j, did anybody get 22.08? So like terms, 3.42i plus 27.19i, 9.40j plus 12.68j. Now, we are actually not done. Almost. So this is our resultant force. And I believe what was asked is find the direction. Express the magnitude to the nearest hundredth pound of a pound and the direction, angle to the nearest tenth. So if we go back to our diagram, so you have force 1, force 2. Now we have some resultant vector, which is going to be, the x will be 30.61 and the y would be 22.08. So you're going to have something that does this. So that's some resultant vector x. And what ends up happening is you see a nice little parallelogram there. I think so. I hope so. So what we're looking for is, if we want the magnitude and direction, we actually need to find the magnitude of this. And then we're going to have to find the angle. So let's do the angle first. Okay? So if you're A, we know that tangent of theta is equal to B over A. So it's going to be 22.08 divided by 30.61. So theta is the inverse tangent of B over A. 22.08 divided by 30.61. All right, ladies and gentlemen, what is angle theta? Okay, 35.8 degrees. Okay, so theta A is so angle theta is 35.8 degrees. Now we also have to be cognizant or mindful of where this resultant vector is. Is it in the first quadrant, second, third, or fourth? This one is in the first quadrant, so we know that it's 35.8. So just like we did with the complex numbers, finding the angle measures, it's important to know what quadrant it's in. Okay, we're still not done. We have one more thing to do, and then we're done. We need this. So we need the magnitude of the resultant force. So that's just the square root of a squared plus b squared. So the square root of 30.61 squared plus 22.08 squared. And evaluating that, we are going to get 37.74. Pounds, yes. So force 1 had a magnitude of 10 pounds. Force 2 had a magnitude of 30 pounds. Now, a big mistake that's easy for us to get drawn into is they'll say, well, what's the magnitude of your resultant force? So oftentimes we want to say, well, it's just 10 plus 30. It'll be 40. That's not the case. In this case, we see that our resultant force is 37.74. Okay, that's because the forces are acting at different angles, so it's not a straight 10 plus 30. All right, almost done. Actually, I think this is all we need. Yep. So our resultant force, our angle direction is the 35.8 degrees, and the resultant force itself is the 37.74. All right, ladies and gentlemen, your homework tonight. Section 6.6, page 783, numbers 71 through 74.